Good morning. We'll be talking about some things this morning, like on the nautical pathway. We understood from previous lessons that the pathway is a way of actually extending our views in terms of the eye perceptions into things that are known and things that are unknown. The pathway tends to be a pathway of waves. A pathway of waves where you have the amplitude and the wavelength, and these waves that tends to be a pattern of eye perceptions or a pattern of perceptions. But here we're going to talk about some things about the nautical pathways. And here we're going to talk about we having the nautical pathway as an equipment or an instrument where we have one magnet here and another magnet here, like what we discussed in the measureship power. We have the positive sign here, we have the positive and negative sign here, the neutrons, and we have the electrons here as the negative, and we have the positive as the protons. Also have that in the opposite magnet. And then we talked about earlier about the attractions of both edges of both opposite edges or polars. The positive and the negative, the positive and the negative, and the neutrons and the neutrons attracting. And this creates an electromagnetic field. And this electromagnetic field is a derivative of the forces that are ascertained in this section. We can actually have an elaborate understanding about this, and this is all about the positive and the negative and the positive, and the neutrons and the neutrons, and then creating an electromagnetic field where you have currents moving. And this current can deflect something, can get into the pathway system, and we can reveal, and it can reveal something, or it can get into a clapper. What we call a clapper or an arrow clapper is what moves like up, right or left, right or left, right or left. So when the shape has a system like this kind of a system attached to it, with the clipper system, when it's moving, and it wants to set the new direction, there is a system that is very variable. The variable system there actually is that as the shape moves, there tends to be something really positive in that the magnetic field here tends to show a resonance movement, and the resonance movement is as a result of the wheel, because this pathway actually is searching for directions, and the direction comes from this pathway, from this small machine, and it is either the clipper moving left or right, and this clipper is moving because this magnetic force here is actually propelling to a certain direction. And we observe that waves actually leaves this machine. Waves comes from this machine into this machine. The machine in the Hamburg shape, opposite, not exactly this, but almost this, in the machine here is kept in here, where you have the two magnets here, and the magnetic force here, one is here and one is here. But the difference here is that one is not having a pathway system. One is just having the magnet system, and the magnet system is here, and the magnet system has what is known as these double pin systems. With these magnetic systems here, having a magnetic field here shows a resonance, and the resonance is attracted to this. And once the resonance is attracted to this, that is outside, what really happens is that this has one of the machines, and this other machine is in the water, moving in the water. So once this shows a movement, a kind of a movement, once it stirs the machine, it's always in an autonomous system. Once it stirs its machines, the machine will be corrected by this machine on the water. This machine corrects this machine because this machine is attached to a pathway. And the only way this machine can recognize this pathway is through this electromagnetic field. So once this machine recognizes this machine, there will be a movement. There will be a movement, a normal movement according to the direction for this shape. For example, if the shape is moving and it's in an autonomous system, the machine here, that's the steer wheel, and the machine here recognizes that's the electrical system here, like almost this here, but it's not having a pathway. Will recognize the frequency ranges coming from this, and once you recognize the frequency range, look at it. It shows waves going to this machine, and it shows another wave coming to this machine here. So there's an in and there's an out coming, and so once an information goes in here, the information gets into this electromagnetic field, and the electromagnetic field gets into this pathway, and this pathway sends a message to New York, and New York send a message to New York, and the direction of New York is sent to this pathway, because this pathway can envisage the patterns or the paths or the directions or the address of New York. And then there's a linear information sent to the pathway again, and the pathway send it to the electrical field again, the electromagnetic field again, and the electromagnetic field sends it again as a wave again. In terms of perceptions, wave perceptions, or normal wave, or modular waves, and these modular waves are sent back to the machines. Let us look at it once more. This is a machine here. It sends frequencies out, and these frequencies, or these waves, modular waves, get into this electromagnetic field, and this electromagnetic field, something reacts in this electromagnetic field. As these waves get here, they tends to get into a directional force, a centrifugal force that moves here, and this centrifugal force is what propels the pathway to move. And as it gets into the pathway, it creates a directional movement in the pathway, and as it creates a directional movement in the pathway, the waves are sent to New York. And once the waves get into New York, it's assigned to an address. And once it's assigned to an address, the address again comes back again. It says, okay, that's the address in New York. It comes back to the machine again, to pathway again, and pathway again designs that address again, recognize that address, that was the address is sent back, and the address comes back again into that machine again, where it goes through a centrifugal force again and comes out of it again and gets into the machine, and there's a confirmation. And so this machine on the water moves. Why the ship follows this machine, and then finally the autonomous system would definitely work very well, because the ship will never lose its direction, will always get to New York, because it's following the nautical pathway. This applies to cars, trains, and other automobiles, airplanes. And I believe with this kind of a system, we'll be able to find what we know as the really nautical pathway for ships, planes, cars, and other automobiles, other auto systems. But this is the basis for autonomous systems. And there's something I want to tell you also. I want to really highlight it again. Let me give you a summary. The summary is that the information in the ship says that he wants to get to New York, and then the waves are sent down into this mesh, into the nautical pathway, and they undergo a centrifugal force based on the reactions between the polar differences or the polar ends, and they get into the pathway, get to New York. Then it is accepted that they've known that the direction has been accepted, or has been known, or from there it is sent back again to the pathway, sent back to the centrifugal force again, and then there's polar reactions again, and it's sent back again to the Hamburg machine again, and then there is this viable word of autonomous. That's how autonomous work. So it follows and this can be in the software. This nautical pathway can be in the software. It might just be a wave like that moving, and then these magnets can be as optic magnets. Optic magnets are like waves. You can make a wave an optic magnet. There is optic in it, in the wave. So if they are optic magnets, then you don't need a machine to float in the water. It's just like a ray coming out of the ship, and it's moving, and that ray has optic magnet, and it has an optical feed, and it has an electromagnetic feed, and then that feed can assess your direction or your destination, and then can bring information back into the ship. Thank you. I hope you enjoyed it. Bye.